Hey everyone, and welcome back for another deep dive. You know we like to cover the latest and greatest in science and tech, and, today we're going way beyond your typical fridge magnets.
Yeah, into the world of cutting-edge physics. We're
Exactly.
talking about a discovery with the potential to, totally revolutionize electronics.
Hmm.
Completely change the game.
So, where are we getting all this from? What's got us so excited?
Well, there's this really fascinating article from SciTech Daily.
Okay.
It's all about something called altermagnetism.
Altermagnetism.
It's brand new, a
Yeah.
new type of magnetism, actually. And get this, researchers at the University of Nottingham, they've actually observed it for the first time ever.
Wow.
It's a big deal.
Yeah, I bet. I mean, it's one thing to theorize about something like this, right?
Right.
But to actually see it, to have proof.
Yeah, it's huge. It's like it bridges this gap between theoretical physics and what we can actually observe and work with.
Totally. So, okay, new type of magnetism.
Right.
Most of us probably think of fridge magnets.
Yeah, the classic.
We think about magnetism. The technical term is ferromagnetism, right?
Exactly. And then there's antiferromagnetism,
Yeah.
where the magnetic moments are aligned in opposite directions. They basically cancel each other out.
Okay, yeah, I remember that from high school physics maybe. So where does this altermagnetism fit in? Is it a completely different thing?
It is and it isn't. Think of it like this. You've got those tiny magnets, but instead of just being opposite, like in antiferromagnetism, they're arranged with a slight twist.
A twist.
Yeah, each group of magnets is kind of rotated a bit relative to its neighbors.
Huh. So it's I don't know, a spiral staircase of magnets.
That's a great way to put it. And that twist, that's what makes altermagnetism so unique and potentially so powerful.
Okay, I'm intrigued. So what's so special about this twist? What does it actually do?
Well, it gives altermagnetism some really interesting properties. It combines the strong magnetic fields of ferromagnetism with the fast switching potential of antiferromagnetism.
Hold on, fast switching. What does
Yeah.
that even mean? In terms of actual technology and stuff.
Okay, so think about our current electronics, right?
Yeah.
They rely on switching the direction of magnetic fields to process information. It's like the fundamental mechanism.
Okay.
But there's a speed limit to how fast we can do that.
Mm.
With altermagnetism, the switching could potentially be up to 1,000 times faster.
Wait, 1,000 times.
Yeah,
That's insane. That's not just a little boost. That's a whole new level.
it is. It's huge.
So how did they actually see this altermagnetism thing? We're talking about stuff happening at the atomic level, right?
Yeah, super tiny. They used a synchrotron.
A synchrotron.
It's this massive X-ray machine. This one was at a facility in Sweden called Max 4.
Okay.
Basically, they shoot these powerful X-rays at a material, and it makes the material emit electrons. And then they use a special microscope to capture and analyze those electrons, and that gives them a picture of the magnetic structure at a nanoscale level.
Wow.
It's mind-blowing.
It's like taking a picture of something unimaginably tiny, and it reveals all these secrets about how magnetism works.
Yeah, it's incredible.
Okay, so we've got this altermagnetism. It's unique. It's potentially revolutionary. But what does it actually mean for, everyday life? How does this translate to something that, I don't know, I might use or benefit from?
Well, think about it. Faster electronics mean faster everything.
Mm-hmm.
Smartphones that are thousands of times faster, data centers that can process information at lightning speeds.
Okay, yeah.
Possibilities are endless.
So it's not just about, my phone loading my Instagram feed faster. This could have a huge impact on, entire industries, right?
Oh, absolutely.
But are there any downsides? I mean, it's got to have some catches, right? It's still early days.
Of course, it's still early.
Mm.
But one really exciting thing the article highlighted was the environmental potential. Replacing traditional components with altermagnetic materials could drastically reduce our reliance on rare earth elements,
And those are.
often mined in ways that are really harmful to the environment.
So not only could this lead to faster technology, but also greener technology.
Exactly.
That's really cool. I did notice that this research was led by a PhD student, right? Alfred Daldin. He spent 2 years on this. It's crazy to think about being that young and already making such a huge discovery.
It is remarkable. It just shows you what's possible. And the fact that this research was published in Nature,
Nature.
one of the top scientific journals in the world, that means it's been rigorously reviewed and is considered super credible.
Yeah, that's a big deal. So now we can actually see altermagnetism. What's next?
Well, now the real fun begins. The research and development.
Mm-hmm.
figuring out how to harness this power.
Ooh, I like where this is going. So that's a perfect place to transition into our next section, where we'll dive even deeper into those very questions. But first, let's quickly recap what we've learned about this altermagnetism thing so far. It's a brand new type of magnetism, with the potential to make electronics faster, more efficient, and maybe even more sustainable.
It's a game changer, really. And we're only at the very beginning of exploring what's possible. Now that we can see it, the next step is figuring out how to actually use it, how to control it, and make it work for us.
Very cool. So it really does sound like we've got this brand new ingredient, this altermagnetism, but now we've got to figure out what to do with it.
It's kind of like, yeah, finding a new spice.
Hmm?
You know it's got potential, but how do you actually use it to make something delicious?
Exactly. So where do scientists even begin with something like this?
Well, I think the first step is just understanding it better, like really digging into the nitty-gritty of how it works,
Okay.
exploring the different materials that exhibit altermagnetism, experimenting with ways to manipulate its properties. And then, of course, the big goal is figuring out how to actually use it, how to integrate it into real-world applications.
Right. So it's not just about understanding it in theory, it's about controlling it, like making it do what we want it to do.
Exactly. It's like, okay, we've got this amazing new tool, but now we've got to learn how to use it. And there are definitely going to be challenges along the way. Like one of the big ones is finding materials that exhibit altermagnetism at room temperature.
Yeah.
I mean, right now, a lot of these materials only show these properties at super low temperatures, which isn't exactly practical for your phone or your computer.
Right. And even if we can find the right materials, I mean, actually building devices with them, working at the nanoscale,
Yeah.
that's got to be insanely difficult.
It's definitely a huge undertaking. But think back to the early days of, silicon-based electronics.
Yeah.
It seemed impossible back then, too. What matters is that we have this spark, this discovery that pushes us to think differently, to invent new things. And I'm confident that with enough research and ingenuity, we can figure it out.
Yeah, that's a good point. It really does feel like we're at the beginning of something huge. And it's not just one team working on this, right? The article mentioned researchers from all over the place.
Oh, yeah, science is a global effort, especially when it comes to big breakthroughs like this. In this case, they needed this huge X-ray machine, the synchrotron, at this facility in Sweden to do their experiments. That kind of international collaboration is essential.
It's kind of inspiring to think about all these brilliant minds coming together, sharing knowledge, resources, all working towards this common goal of understanding something new. So going back to those environmental benefits you mentioned, reducing our reliance on rare earth elements, that could be massive, right?
Yeah, it could be a game changer, for sure. I mean, right now, so many electronic components rely on these elements, and a lot of times they're mined in really harmful ways.
Yeah, not good.
Altermagnetism could offer a much cleaner, more sustainable way to do things.
And of course, there's the energy savings too.
Oh, yeah, for sure.
Yeah.
If we can make electronics more efficient, that means less energy consumption overall, which is huge, especially with climate change and everything.
It's like this chain reaction. Faster, more efficient technology, less energy consumption, healthier planet.
Exactly. It all ties together.
It really does seem like a win-win. This isn't just about cool new gadgets. It's about addressing some of the biggest challenges facing our planet.
It's about using our knowledge to make a real difference, to create a better future.
Okay, so I gotta admit, all this talk about the potential is really getting me curious. What would a future powered by altermagnetism actually look like? What are some concrete examples of how this could actually change things?
All right, let's start with something close to home. Your smartphone.
Okay.
Imagine a phone that boots up instantly. Like as soon as you touch the button, it's ready to go. And downloading movies, seconds.
Ooh, I like that.
And those complex augmented reality apps that are just starting to come out, it can handle them no problem.
Okay, that's pretty cool. But what about beyond our personal devices? How could altermagnetism impact entire industries?
Well, think about the field of medicine. Faster processing speeds could revolutionize medical imaging, making diagnoses quicker and more accurate. Treatments can be tailored specifically to each patient's needs based on real-time data.
Wow.
And in the realm of scientific research, simulations that currently take weeks or months could be completed in a fraction of the time.
Yeah.
It could lead to breakthroughs in fields like drug discovery, material science, you name it.
And AI. We can't forget about AI.
Oh, absolutely. That's a huge one.
Mm-hmm.
AI development is already pushing the limits of our current computing power.
Right.
Altermagnetism could give it the boost it needs to really take off.
It's mind-blowing to think about the ripple effect this could have, accelerating progress in so many different areas. But with all this potential, we have to talk about the potential downsides too,
Yeah.
the ethical considerations. I mean, any new technology comes with risks, right?
Of course. It would be irresponsible not to acknowledge that. One concern is the potential for misuse. That speed and efficiency we've been talking about. It could also be harnessed for malicious purposes.
Like what?
Think about things like hacking, cyber warfare, even autonomous weapon systems that can react much faster. These are serious issues that we need to address.
Yeah, that's definitely something to think about. So as we move forward, how do we balance the excitement of this new technology with the responsibility of using it ethically?
Well, I think the key is open dialogue and transparency. We need scientists, policymakers, ethicists, everyone to be involved in these conversations about the potential impact of this technology.
So it's not just about the scientists in the lab, it's about society as a whole having a say in how this unfolds.
Exactly. We need to establish clear ethical guidelines and regulations for the development and use of altermagnetism. And that requires collaboration on a global scale.
It's a big responsibility, but also an exciting opportunity, right? I mean, we have a chance to really shape how this technology impacts the world.
Absolutely. This is about more than just science. It's about deciding what kind of future we want to create.
And that brings us to a really important point. It's not just about the scientists and policymakers. It's about all of us. It's about all of us engaging in these conversations, being informed, and ultimately helping to shape the future of this technology. So where do we go from here? What are the next steps in this whole altermagnetism journey?
Well, it's important to remember we're still really early in this whole process.
Yeah.
We've just scratched the surface.
Yeah, true.
There's still so much we don't know about altermagnetism. It's like we've discovered this new continent, but we've only just stepped onto the shore.
Ooh, I like that analogy.
There's a whole vast, uncharted territory out there just waiting to be explored.
It's pretty exciting to think about all the other groundbreaking discoveries that might be out there just waiting to be found.
Yeah, and that's what drives science, right? That sense of wonder, the constant pursuit of knowledge. It's about pushing the boundaries of what we know, and often those answers lead to even more questions.
And those questions lead to more discoveries. It's like this amazing cycle.
Exactly, a cycle of curiosity and innovation.
Okay, but let's bring it back down to earth for a second. What are some of the concrete next steps in the research and development of this?
Well, as we mentioned before, one of the big hurdles is finding those materials that exhibit altermagnetism at room temperature. That's crucial for making it practical, for everyday devices.
Right. If it only works when it's super cold, that's not going to be very useful for most of us.
Exactly. And beyond that, it's about control. Learning how to manipulate the properties of altermagnetism, how to fine-tune it for different applications.
It's like we need to learn how to speak its language.
Yeah, exactly. Like, how do we tell these tiny magnetic twists what we want them to do?
It sounds pretty complicated.
It definitely is. It's going to take a lot of collaboration between physicists, material scientists, engineers. It's a team effort.
And as we move from the lab to the real world, I keep thinking about those ethical considerations. How do we make sure that altermagnetism is used responsibly? How do we prevent those potential downsides we talked about?
Well, it starts with open communication. Scientists, policymakers, ethicists, even the general public. We all need to be part of the conversation about the implications of this technology.
So it's not just about the science, it's about having those tough conversations about ethics and society.
Exactly. We need to establish clear guidelines, regulations, make sure this technology is used for good, and this has to be a global effort.
I'm sensing a theme here, collaboration. It seems like that's crucial at every stage.
It really is. It's about recognizing that scientific progress doesn't happen in isolation. We have to think about the broader impact, the potential consequences, and make sure we're using this knowledge responsibly.
And that's where education comes in.
Absolutely. The more people understand about altermagnetism, the better equipped we'll be to make informed decisions about its future.
So it's not just on the scientists, it's on all of us.
Exactly. We all have a role to play in shaping the future of this technology.
And that brings me to, I think, the most important question of all. Now that we have this glimpse into the potential of altermagnetism, what kind of future do we want to build with it?
That's a good one. A really good question. It's a question that demands careful thought, open discussion, a willingness to embrace both the possibilities and the challenges.
It's exciting and a little daunting all at the same time. Well, on that note, I think we'll leave our listeners with that thought-provoking question to ponder. Thanks for joining us on this deep dive into the world of altermagnetism.
It's been a pleasure. We hope you learned something new, and who knows, maybe this sparks some ideas about what the future